Myself K. Sirisha, working as Assistant Professor in MBR College of Engineering and Technology in Mechanical Engineering Department. Now we are going to solve the optimization methods. In optimization methods, we have two methods. One is stepping stone method, another one is modist method. Now we are going to do one method. One of the method is stepping stone method. Before solve the stepping stone method, we have to solve the initial feasible solution. By taking this initial basic feasible solution, the after that initial basic feasible solution, after that we can find out the optimum solution value. Now we can take any one of the methods. If he is mentioned, we can take that method only. If he is not mentioned, we can take a northwest corner method, least cost method, or Vogel's approximation method. Any one of the method you can choose, and find out the initial basic feasible solution. Now in this problem, I will take Vogel's approximation method. If he is not mentioned any method in the given problem, you can take any one of the methods. Okay, now I can take this method. So that method is Vogel's approximation method. Already we know. First of all, we can check the total supply and total demand. Our total supply is 34, our total demand is 34, so supply is equal to demand. Now you can find out the initial basic feasible solution by using the Vogel's approximation method. So here is the problem. Okay, so this is the destinations D1, D2, D3, and sources 1, 2, 3, 4, and demand is there and supply is there. Now we know that first we will start with penalty 1. So what is the start with penalty 1? So first minimum and second minimum. Here first minimum is 2, second minimum is 4. So subtract the second minimum minus first minimum. 4 minus 2. 4 minus 2 is 2. And here first minimum is 1 and second minimum is 3. So second minimum minus first minimum 2. And another one is 4 and second minimum is 5. So second minimum minus first minimum, 5 minus 4, 1. And like that 1 and 2, 2 minus 1, 1. At the same way here also penalty 1. So 1, 2, 2 minus 1, 1, 3, 4, 4 minus 3, 1, and 1 and 2, 2 minus 1, 1. We can select maximum value of penalty P1. Here we have maximum value is 2. Maximum value is 2, but we have two maximum values. How can you find? So we can add all the values of destinations. 2 plus 7, 9, 9 plus 4, 13. So total is 13. Here 6 plus 1, 7. So 13 and 7, which is minimum? 7 is minimum. So which is minimum? So that value you can select here. Select like here. Okay. So you can add total destination 2 plus 7, 9, 9 plus 4, 13. So 13, 3 plus 3, 6, 6 plus 1, 7. So 13 and 7, which is minimum? 7. So that minimum value we can take like this value as a maximum. So in this maximum value you can select minimum value. So this is our minimum value, and here 18. So can check the supply and demand. Here supply is 8, demand is 18, and put minimum value here and cancel this 0, and we have 10 units. Okay, so which is 0, and just cross this. And next penalty P2 we can take same 4 minus 2, 2, and this cell is not there. And next 5 minus 4, 1, and next 2 minus 1, 1, and next here P2 2 and 1, 1, 2 minus 1, and here 6 and 4. So 6 minus 4, 2, and next 2 and 4, 4 minus 2, 2. Here also same like that. Here also same. So what should we do? Here we check the P2 penalties. and we can select the maximum value. Okay, we can select the maximum value. Here 2, here 2 is there, and here also 2. How can we can select 7 plus 2 9, 9 plus 4 13. Okay, 13, and we can select here, we can select like here, and 7 plus 4 6 plus 4 10, 10 plus 7 17. Okay, so this is 13, this is 17, and 7 plus 2 9, 9 plus 4 13. Here it is 13 and it is also 13. So you can choose here 17, 13, 13. We can choose minimum value. Here I can choose here, I can choose like here. So 7 plus 7 8 9, 9 plus 4 13, and it is also 13, but I can choose 13 here. So I will select 2 here and select minimum value. 2 is minimum value, so 2 is minimum value. I will select minimum value and place 10 here, and it makes 0. So carry 4, and which is 0, just cross it. Okay, now P3, so 7 minus 2 5, 7 minus 2 5, and this row is not there. And next 5 minus 4 1, and this cell is cancelled because of 6 minus 1 5, and P3 1 and 2 1, and next 6 and 4 2, 6 minus 4 2, and this row is cancelled. Here also same like that. Here 5 is 5, we can select maximum value, and here 5 and 5. So 7 plus 2 9, 6 plus 1 7. So which is minimum? 9 and 7 is minimum. So I will select 5 and select the minimum value. 1 and 6, which is minimum? 1 is minimum, so here is 4, and we put 4 here, and 7 minus 4 3, and 0. Okay, so which is 0, and just cancel this. And next P4, 7 minus 2 5, and next this row is not there. 5 minus 4 1, and this row is also not there. And next 5 minus 2 3, P4, 7 minus 4 3, and this column is cancelled. Here 5 is maximum, and select and take minimum value is 2. So supply is 5 and demand is 3. Select minimum value, and it makes 0. 5 minus 3 2, and just which is 0, and just cancel this. Okay, and penalty P5. Finally we have 7, and this row is cancelled. Here we have 4, and this row is cancelled, and this row P5, this column is cancelled, and here 7 minus 4 3, and this column is cancelled. Finally we have 7 and 4 and 3. 7 is maximum, and select minimum value. So 7 is the minimum value, 7 is the value. Here only one value, here 2 and 9, which is minimum? 2 is minimum, and take 7, and it makes 0, just cancel it. Okay, and next P6, and this row is not there, and this is also not there, and we have 4, and this row is also not there, and P6, this column is not there, this column also we have only 4, and this column is also cancelled for P6. So here 4 and 4, any one value you can select. Here 4 is only one, here also 4. So 7 and 7 both are cancelled, 0 and 0, and finally we have 7. And now we are going to minimum transportation cost. So for minimum transportation cost, 2 into 3 plus 2 into 7 plus 8 into 1 plus 4 into 7 plus 4 into 1 plus 2 into 10, and finally we get the value of we will get the value of 80 rupees. 6 plus 14 plus 8 plus 28 plus 4 into 1 plus 4 plus 20 is equal to, finally we get 80 rupees. So our initial basic feasible solution is 80. Now we are going to check another step. So that is non-degeneracy. Check non. Actually in previous class I think I put degeneracy, so I will check non-degeneracy. M plus n is equal to number of allocations. Okay, here m is number of rows, 1 2 3 4 4 plus, and number of columns 1 2 columns is equal to number of allocations 1 2 3 4 5 6 is 6. And number of columns is 1 2 3, not 2 3. So 4 plus 3 7 minus 1 is equal to 6. 6 is equal to 6, and therefore it is a non-degeneracy. Now we are going to start. Third step is find optimum solution, optimum solution. For optimum solution, I will take the table is 2. Already we take initial basic feasible table, so this table we will consider here. So what is the table is 2 7, so 2 power 3 7 power 2. Already we found that initial basic feasible solution, 4 3 3 8. So what we find here, so we take just this table. Okay, so 5 4 7 1, so 1 6 and 2. So this is our table. This is our initial basic feasible solution. This is destinations, and this is source, and this is supply, and this is demand. So this is demand. So demand is 7, 9, 18 and supply is 5, 8, 7, 14. Okay, so this is demand and these are destinations. Now cell evaluation, we take cell evaluation. What is cell evaluation? So which is a non-allocated cell, that is our cell allocation. So this is first row, third column. So C first row, third column, C1, 3 is equal to, and next two non-allocated cells. So second row, first column, and next second row, second column, and next third row, first column, next third row, second column, next third row, third column. Okay, this is fourth row, second column. So this is our cell evaluation. Now we are going to find out how to allocate the cell evaluation for each. So this is our this is the initial basic feasible solution table. So this is our cell evaluation or net change. So now we are going to find out the each cell evaluation. First one is which is not allocated, so that is we called as C13. So here 4 is non-allocated, so this is first row, third column, and this is second row, first column, second row, second column, third row, first column, third row, third column, fourth row, second column. So these are our cell evaluations or net change. Now we are going to find out the values of these cell evaluations. So here 1, 3. So this is we will start this this cell, and so we can you can take a loop. So when you start this number, so definitely when we go to the next number, definitely it have one allocated cell. So 4 to 1 is, this is one allocated cell, but the next number also which is allocated, but here there is no any allocated. So 4 to 1, here 4 to 1, so here one allocated cell, and 2 to 1 is another allocated cell, and 1 to 2 is another allocated cell, and finally and close to our loop. So when we start with this number, and next term also allocated, and next term also allocated, and next term also allocated. So when you started this number, this is considered as positive, negative, positive and negative. So we will take this cost values. So what are the cost values? Plus 4 minus 2, plus 4 minus 2. So this is plus 1 and this is minus 2. So plus minus plus minus. Okay, so plus 4 minus 2 plus 1 minus 2. So this is our cost evaluation for C13, and finally minus 2 minus 4, minus 2 minus 4 plus 4 0, and we got 1. Okay, and next 2, 1, this is the 2, 1. When you start this cell, so I will start here. So next we will go to one allocated cell. Here it is one allocated cell, and this is here one allocated cell, and finally close this loop. And this is positive, negative, and this positive, and this is negative. So finally we got 3 plus 3 minus 1 plus 2 minus 1 minus 1. So plus 3 minus 1 minus 2 minus 1, sorry, plus 3 minus 1 plus 2 minus 1. Okay, so minus 1 minus 2 plus 2 minus 2 cancel. Finally we have 3. At the same way the next procedure also same. So next our cell is Next our cell is 2 comma 2. So 2 comma 2 is this. So I will start this cell, and next this cell, and next this and next so I will start this cell. Now I start this cell and this cell and this cell, and next, so I will start this cell, and next this loop, and next this loop, and next go this loop, and go this loop, and finally we got this cell. Okay, so our loop is like that. Our loop is like that for 2 comma 2. I will clearly mention when I mention the material, it is just the procedure I am saying. So finally this is plus, and this is minus, plus, minus, plus, and this is minus. Okay, so plus 3, when it is started with plus 3, and this is minus 1, and this is plus 2, and this is minus 1, and this is plus 2, plus minus like that. So cell is 7, minus 7. So this is, so plus 3, minus 1, plus 2, minus 1, plus 2, minus 1. Finally I got minus 2. So here same like that, 3 comma 1. So third row first column, this is third row first column this. So when we start this cell, there is no any loop we cannot find. So when we start this cell, here this is 3 comma 1. So we go to this cell and this cell and this cell, and find our loop is completed. So this and this, finally our loop is completed. So positive, negative, positive, and negative. Okay, so when you started this cell, and our loop we can form, and when you are close to the loop, definitely it is an allocated cell. So here plus 5, minus 2, plus 5, minus 2, plus 7, minus 4. Finally we have 6. Same like 3 comma 2. So third row it is 3 comma 2, it is 3 comma 3. So third row, third column is 7. Now start with 7 and this cell, 7 to this cell and this cell. Next there is no, so this cell and this cell and this. So this loop is formed like it. Start with this and start with this, and next this loop, and next this loop, and finally reach this one, and go with this cell, and finally this. Okay, so start with 7. So you can observe these numbers. Okay, so this is plus 7, this is plus, minus, plus, minus, plus, minus. So plus is 7, and next plus, minus 2, this is minus 1, and this go to another cell is minus, plus 2, and next minus 7. So whatever the loop, if we will start with the positive, so next after that negative, positive. So next minus 7, and next go this cell, plus 4. So this is like that, and finally we got 7. Next 4 comma 2. So this is our 4 comma 2. I will start this cell. So next our allocated cell, next our allocated cell, next our allocated cell, next. So this loop is formed like that. So this loop is formed like that. This loop is formed like that. Okay, finally I got plus 6, minus 1, plus 2, minus 7 is equal to 0. I will mention the given material. You will observe very clearly. So those are answers. In our cell level cell evolution, we have only 0 and positive values. So if you have 0 and positive values, our solution is optimum. Okay, our solution is optimum. But if you have negative values, our solution is not optimum. You can check in our cell, in our net change values is negative. 1 is positive, 3 is positive, but we have one negative value, and 6, 7, 0. Okay, so if any one of the negative values there, our solution is not optimum. Just it is not confusion, just you will observe these numbers only, we can find a loop. Okay, I will just draw this one diagram. You can take each and one cell. I will put I mentioned the material in our description also, you can find out. I am drawing each cell table also. Okay, it is not tough. You just observe this number and find the loop. Okay, so here one negative value is there, one negative value. So how can avoid this negative value? So you can take the here in this evolution, cell evolution, we have one negative value is there, so we can avoid this negative. So how can we do? So take the initial basic feasible solution table. So here we have negative is cell of 2, 2. This is cell of second row, second column, and start the loop for what is the loop our? So 3. So plus 3 minus 1 plus 2 minus 1 plus 2 minus 7. Okay, and close this loop. So you can here observe and start with one loop and end with 2 only. Okay, so this is positive, negative. So when it is start with positive, so this is negative, this is positive, and this is negative, and this is positive. Okay, so how can we take? So what is the negative value? What is the negative here? And all of that, what are the negative? Okay, positive, positive, negative. This is positive, and this is negative, and this positive, and this is negative. Here negative is 7th cost and its allocation is 2, and next negative is here and cost is 1 and at allocation is 2, and next negative is this is 1 and its allocation is 4. So in this values, select minimum value, select, so negative values, so select minimum value, here 2 is minimum, so this 2 is added each allocated cell. So here symbol is plus, so 3 plus 2 5, so 2 this is 5, 3 plus 2, so this is 3 plus 2 is 5, this is 3 plus 2 is 5, and next this is negative, sorry, here there is no any, so 2 minus 2, so here symbol is negative, so 2 minus 2 is 0, there is no value here, and next there is no value here, there is no value, but this is our loop, so plus is there, so plus 2, so here we can allocate one cell. So which should the loop we are considered that loop, we will allocate the cells. Here this is the loop, so 1 power 8, nothing but allocated cell is 8, but here 9 minus 8 minus 2 6, here plus 10 plus 2 12, and 4, and the negative is there, and 4 minus 2 2. So I will take here, so I will take the values here and find the, and again initial basic feasible solution, and its minimum cost is 5 into 2, 3 into 6, 1 into 6, 2 into 1, 4 into 7, 2 into 12 is 76. And again we will consider cell evaluation. So how to take the cell evaluation, which is unallocated cells. So first row, second column, 1 2 1 3, 2 1, 3 1, 3 3 and 4 2. So those are our cell allocations. And the previous one, we can take the loops. For example, 1 comma 2. So this is our 1 comma 2. So take the loop like that. So this is positive, start with the positive, and next minus 3, minus 1. So minus 3 plus 1, minus 2 plus 1 and 2. The loop is like that only. So start with this and this and this and this and this and close like this. So this is our loop. Okay, so and each cell we will consider like that only. So finally we got these values. Okay, and all cells are here. We will observe 2 1 3 4 5 2. So all values are positive. So all cell value evaluations are positive. So optimal solution is obtained. So minimum cost is 76 rupees. So this is our, we can just a little bit confusion here only. I given the material and each cell I will consider the each loop, so you can better understand. So finally our cell evolution has all positive values, and finally if you have positive values, and therefore optimal solution is obtained. So this is our minimum cost 76 rupees.